Hi guys, this is your introduction into energy. You're going to be expected to understand the concepts presented as well as solve the problems shown in this lecture. Alright, so I imagine you've been on a roller coaster, if you're not afraid of heights or too afraid of heights. You can watch the link I'll put the link in your Google Classroom. You can watch that. And then you can try to see, how is this related to what we're talking about? So energy. So what is energy? It is the ability to change the environment or the ability to do work. So our previous lesson, we're talking about work, force times displacement times cosine theta. Now we're correlating that with energy, and it's the ability to do work. Energy and work are both scalar quantities, and they're both measured in joules. So kind of keep that in mind. They're both scalar and measured in joules, capital J. So you can see they're different types: light energy, heat, chemical energy, kinetic energy, and electrical energy. So it can be divided up or classified into kinetic energy or potential energy. So kinetic energy is motion and potential is stored, which kind of makes sense. So stored mechanical energy, nuclear, chemical, gravitational are all types of potential energy. Electrical, light, heat, movement are examples of kinetic energy. So we're going to focus in our unit, we're going to talk about gravitational potential energy and the energy of movement. So we're just going to call that one kinetic energy, but we're going to try to be specific with this one, and you'll see in a bit. So kinetic energy, gravitational potential energy. As you can see here, the potential energy and kinetic energy are all kind of related, so to speak, or within one system or in one instance, if you will. The potential energy and the kinetic energy are both correlated somehow. And we'll get more into that when we get into our unit, as we get more into this topic. So kinetic energy is measured in joules. So it can either be, the symbol is capital KE or just K, and it's the energy of a moving object due to its motion. The formula is KE equals half mv squared, where your kinetic energy is in joules, your mass is in kilograms, your velocity is squared, and it's meters per second. To increase our kinetic energy, we can either increase our mass, which I can do rather easily because I eat a lot, or you can increase your velocity. More likely, you can increase your velocity to increase your kinetic energy. So your particle moves with the speed of 20 meters per second. So you can say that's our velocity, and has 150 joules of energy. What was the particle's actual mass? So let's say that this is our V. This is our kinetic energy. What is the mass? Ke equals half mv squared. I'm trying to solve for this. So be careful that you don't try to cancel out these two, because I think there may be a temptation to do that, so don't do it. So Ke, I'm going to rewrite this a different way. Ke equals mv squared over 2. So I just distributed the half. I want to get the mass by itself. So I'm going to multiply both sides by 2 over v squared. And why am I doing that? I am doing that simply to cancel it out on the side with the mass, so that all I'm left with is just the mass itself. So 2 times 150 joules divided by 20 meters, all of that is squared. That is my mass. 150 times 2 divided by 20. The mass is 0.75 kilograms. calculate the kinetic energy of a 1,200 kilogram moving car. It's moving at 24 meters per second. So this is fairly easy, fairly straightforward. So kinetic energy, mass, velocity, KE equals half mv squared. So half times 1,200 kilograms times 24 meters per second squared. All of that is squared. So 24 squared, so 576. 1,200 divided by 2, 600. So you can just distribute all of that if you want. Just multiply it out. So 345,600 joules. So gravitational potential energy, it's determined by an object's height. So the higher an object is, the greater its potential energy. That's why Spider-Man he's building up potential by just laying there, supposedly. Potential energy is mass times the magnitude of gravity. So this is 10 meters per second, but let's do 9.8 meters per second squared. With the height, and it's in meters. The gravitational potential energy is directly proportional to its height. So if I'm increasing my height, I'm going to increase my potential energy. Similarly, if the G is the same and H is the same, if I increase my mass, I can increase the potential energy, but it's easier to increase your height versus your mass. So knowing that the potential energy at the top is 50 joules, what is the potential energy at each of the positions? So if you'll notice that on the bottom level of the stairs, the potential energy is 0. So that means that even though it's rolling down an incline or just dropping, my potential energy at E and and F is 0 joules. You can kind of figure out from here that these are equal in height in each. So A is 40 joules, B is 30 joules, 20 joules, and then 10 joules. The potential energy of a refrigerator at the top of 104 hotel or 27 meters is 12,150 joules. What is its mass? So I'm trying to find the PE. So this is my PE, I'm sorry. This is my height, my mass. G you already have at 9.8 meters per second squared. That's just the magnitude with it. We just want the magnitude, so that's just the number and the unit, not the direction. So the potential energy, mgh, solving for mass, divide both sides by gh. 12,150 joules divided by 9.8 meters per second squared, and all that, 27 meters out on the bottom to get my mass. So 12,150 divided by the denominator, 45.918 ... So let's say it's 46 kilograms. All right, so that's it for this lecture. Let me know if you have any questions. Thanks, guys.